Okay, guys, we are in chapter carbon and its compounds. Today, we need to learn about homologous series. I'll tell you what is meant by homologous series. Meanwhile, let us see few basics what we have learned in these lectures. So, first, carbon. Carbon is represented with the letter C. Its atomic number is 6. Mass number is 12. It has 6 electrons, 6 protons, and 6 neutrons. And atom is neutral always because equal in magnitudes of charges. It has -6 plus 6 equals 0. So always atom is neutral. If you write electronic configuration, it is 1s2, 2s2, 2p2. Outermost orbit is 2s2, 2p2. If you want to draw electron dot structure for carbon, see 2s2, 2p2, 2 plus 2, 4. So 1, 2, 3, 4 valency electrons are there. Now this carbon to become stable, it will share 4 electrons with 4 other elements maybe, or it can share with 3 elements, it can share with 2 elements, or it can share with 1 element, something like that. So to become stable, bond it will share, and that bond is known as covalent bond. So covalent bond is nothing but bonding between two elements or two atoms by means of sharing of electrons. So from now, how to represent that carbon? Carbon with 4 bonds. What is the meaning of these lines? It is ready to get bond. Now, carbon can form single bond, carbon can form double bond, carbon can go with triple bond also. Then what we have learnt in last lecture, there are two types of compounds, saturated and unsaturated. Before that, you have to understand first compound. Compound is nothing but combination of atoms, right? Atom plus atom, two or more, it's wish. So if atoms are combined together, it forms compound. So if atoms are identical, it will become an element. If atoms are different, it can become molecule or compound. You are familiar with that. Next, we have another compound, that is carbon compound. What is meant by carbon compound? In these elements, if one of the elements is carbon and remaining different atoms might be hydrogen, chlorine, bromine, iodine, oxygen, etc. If it is like this, you can call that one as carbon compound. We have another compound. Regarding that, what we are going to see in this lecture, that is hydrocarbon compound. What is meant by hydrocarbon compound? It is quite simple to understand. Two or more atoms should combine, right, to form compound. If one is hydrogen and another one is carbon, then it is known as hydrocarbon compound. There should be only hydrogens and carbons, not any other element. So is that possible? Means yes, it is possible. Hydrocarbon compounds are two types. First one, saturated hydrocarbon compound. Second one, unsaturated hydrocarbon compound. What is saturated? If you find single bond, we can call that one as saturated. Whenever you see at least one double bond between carbon, or at least you have to see one triple bond between carbon. Guys, not between any other element. Single bond, double bond, triple bond should be between carbons only. Between carbons only. You have to understand that. So single bond, you know how to represent? That is represented like this. Double bond represented like this with the 2 lines. Triple bond represented with 3 lines. Next. Today's topic is homologous series. You are familiar with the word homo, series, etc. What is meant by homo in biology? What we can learn? Identical, nothing but homo. In chemistry 9th class also we have got homogeneous and heterogeneous mixture. What is homogeneous mixture? In 9th chapter, 2nd chapter, you might have learned. Homogeneous, nothing but if you have same type of compounds, if you have same type of molecules or same category, it is known as homogeneous. So solution which is made up of same type of molecules, compounds. Now, what is homologous series? If a structure, if one structure, that structure is repeating, if the structure is repeating, we can call that one as homologous. And if you write in form of a series, that is known as homologous series. Simple. I'll explain you what is that repetition, how it will repeat, that we'll discuss now. So to learn that homologous series, we have to understand saturated and unsaturated. While coming to saturated, we have alkane. While coming to unsaturated double bond, we have alkene. While coming to triple bond unsaturated, we have alkyne. What are those? Alkane, alkene, alkynes means it is a homologous series of hydrocarbon compound. They gave name. Simple. We can call human beings. So name by name, we cannot call everyone, right? So we have some millions of people. What we can do, we can categorize them as human beings. We have many fruits. We can categorize them as fruits. Vehicles, like that. Homologous series, we have many chemical formulas. So like that, what are the homologous series? It has single bond. Everything will come under alkane. So alkane means there will be only single bond homologous series or single bond hydrocarbon compounds. Alkane means at least one double bond. How many? At least one, minimum one double bond should be present between carbons. Then all those double bonded homologous series, that category is known as alkene category. Alkyne means at least one triple bond should be present between carbons. And if you draw structures and if you find some hundreds of structures, some hundreds of hydrocarbon compounds with a triple bond, all those hydrocarbon compounds will come under category alkyne. So alkane, alkene, alkyne, alkanes single bond, alkene double bond, alkyne triple bond. These are categories. Try to understand. And we have formula, alkane formula CnH 2n plus 2 alkene CnH 2n alkyne CnH 2n minus 2. In place of n, we can substitute numbers from 1 to your wish. Now, if you substitute 1, C1, right? If you substitute 2, C2. If you substitute 4, C4. Means if you are increasing the numbers, carbon counts are also increasing. Now, if carbon counts are increasing, what to call those carbons? That we'll try to understand. If there are here, let us try to count carbons. If there is one carbon, we have to pronounce that formula or that compound name with meth. If there are two carbons, eth. If there are three carbons, prop. If there are four carbons, but. If there are five carbons, pent. If there are six carbons in that series, six carbons in the compound, we have to call it as hex. So try to remember meth, eth, prop, but, pent, hex. Of course, we have 7, 8, 9, 10, 11. It will be going on. But in your 10th class, if you remember these six, more than enough. So 7, we can go with sept, 8, oct, 9, nano, nan, nano or nan something, 10, deca, dec, like that. You can observe like months, September, October, November, December, like that. Yeah, we got names of the months from this only. Okay, try to remember up to 6. Where it is used, I'll teach you now. Okay, you see, alkane, alkene, alkyne, right? If you substitute 1, it will become what? C1H, 2 into 1, 2, 2 plus 2, 4, C1H4. If you substitute 1 in alkene, it will become C1H2. Practically, this molecule or compound is not formed. We cannot get this. If you substitute 1 here, it will become C1H, 2 into 1, 2, 2 minus 2, 0. Practically, this compound is also not obtained. Now substitute 2. If you substitute, it will become C2, 2 into 2, 4, 4 plus 2, 6, C2H6. Substitute 3, C3H, 3, 2 into 3, 6, 6 plus 2, 8, C3H8. Substitute 4, C4H, 4 2s 8, 8 plus 2, 10. Substitute 5, C5H, 2 5s 10, 10 plus 2, 12. Substitute 6, C6H, 2 6 12, 12 plus 2, 14. Now substitute 2 here. In alkene group, C2H, 2 into 2, 4. C3H, 3 2s 6. C4H, 4 2s 8. C5H, 5 2s 10. C6H, 6 2s 12. Now substitute 2 3 4 5 in alkyne group. You will get C2H, 2 2s 4, 4 minus 2, 2. C3H, 2 3 6, 6 minus 2, 4. C4H, 2 4s 8, 8 minus 2, 6. C5H, 5 2s 10, 10 minus 2, 8. Last 6, C6H, 6 2s 12, 12 minus 2, 10. Okay, we see like that we can get C7, C8, C9, C10, C50, C51, C52, C100, like that we will be getting it. We will be getting. Now how to name? So to name this, we have two parts. To name this, we have two parts. First part, carbon part. Second part, category part. So first part, carbon part. How many carbons? One carbon. One carbon means what to say? Meth. So you can write this one as meth. Here, it is coming under what category? Alkane category. So if you are representing alkane, that suffix ane. Suffix is ane. That should be added. ANE, methane. Next, here 2 carbons means eth. Eth. 3 carbons means prop. 4 but. 5 pent. 6 hex. Here also same. 1 carbon it is not possible, leave it. 2 carbons eth. Here 2 carbons eth. 3 carbons prop. 3 carbons prop. 4 carbons but, not but, but. 4 carbons but. 5 carbons pent. 5 carbons pent. 6 carbons hex. 6 carbons hex. Now while you are writing that category, if alkane category, you have to go with ane. If this is alkene category, we have to go with ene. If it is alkyne category, we have to go with ine. So if you add those suffixes, it will become ane, isn't it? It is ane. So methane, ethane, propane, butane, pentane, pentane, hexane. Now this is alkyne category, sorry, alkene. So ethene, propene, butene, pentene, hexene. This one alkyne category, ethine, propine, butane, pentine, hexine. Very simple and easy, isn't it? So whenever they give you formula, let us, you can take this one screenshot. This must be present in your running notes. Now let us try to draw structures also for this. Then easily you can understand. Okay. Now if they give formula, how to write its name? For example, if they give C4H10, C4H10. Now how to name this? First count number of carbons, 1, 2, 3, 4. 4 means meth, eth, prop, but. So it is but. Now you see the relationship between 4 and 10. 4 and 10 into 2 plus 2, or only into 2, or into 2 minus 2. You see, in this only 1 will be there. 4 into 2, 8, 8 plus 2, 10. Yes, 4 into 2 is 8. No, 4 into 2, 8 minus 2, 6. No, here we are getting 10, right? So it is into 2 plus 2. Into 2 plus 2 means ane. Only into 2 means ene. Into 2 minus 2 means ine. So it is ane. Answer is butane. If they give like this, C3H6, how to name this? 3, meth, eth, prop. Prop. You see this relationship between this 3 and 6. Into 2 plus 2, into 2, into 2 minus 2. Into 2 plus 2 means 6 plus 2 should become 8. Into 2 means it should become 6. Into 2 minus 2 means it should become 4. So it is neither 8 nor 4, it is 6. So middle, that is ene. So answer is propene. Right? So like that, another thing, C5H8. So C5, 5 carbons, meth, eth, prop, but, pent. Pent, relationship between 5 and 8. Into 2 plus 2, into 2, into 2 minus 2. Into 2 plus 2 means 5 into 2, 10 plus 2, 12. Into 2 means 5 to 10. Into 2 minus 2, 10 minus 2, 8. So neither 12 nor 10, it is 8. So last, that is ine. So answer is ine, pentine. Like that, easily we can name and identify homologous series of hydrocarbon compounds. Like that you need to. So you can take this screenshot, names of the compounds. Methane, no methane, no methane. It is not possible. Ethane, ethene, ethine. Propane, propene, propine. Butane, butene, butine. Pentane, pentene, pentine. Hexane, hexene, hexine. Next, carbon compounds count. You can take this one screenshot. 1 means meth, 2 means eth, 3 means prop, 4 means but, 5 means pent, 6 means hex. And how to name? Simple. Very easy to understand. So till now we have seen names, and if you observe pattern which is continuing, CnH2n plus 2, that is continuation, isn't it? So everything, you see, formulas of CnH2n plus 2 will come under category alkane. So homo, we can say. Homo, and it is continuing logous, and that is in form of series, that so that only this is known as homologous series. Now let us try to draw bonds. Very important. In examinations they will ask you to draw. So everyone must draw along with me such that you can able to understand. So first, let us take alkane. Alkane formula we know, Cn, general formula Cn H2n plus 2. Now, if you substitute 1, 2, 3, 4, 5, 6, it will become C1. No need to represent 1. You can leave it. C1 H 2 2s, sorry, 2 ones, 2 plus 2, 3. Sorry, here. 2 into 1, 2, 2 plus 2, 4. CH4. You can represent as C1H4 or CH4, no problem. If you substitute 2, it will become C2H, 2 2s 4 plus 2, 6. 3, C3H, 3 to 6 plus 2, 8. If you substitute 4, C4H, 4 2s 8 plus 2, 10. Like that. C5H, 12. Right. And last, C6H14. And while coming to names, methane, ethane, propane, butane, pentane, hexane. Now we have to draw structures. Let us try to draw. Now you see the formula CH4. How many C's? 1. So always you can make carbon as center point. Now CH4. C, for a carbon, how many valence electrons? 4. So you have to draw definitely 4 bonds. 1, 2, 3, 4. And how many hydrogens? 4. You can represent hydrogen 1, 2, 3, 4. Guys, what is the meaning of these lines? There is one electron for this carbon which is bonding with another electron of this hydrogen. So this line is for carbon as well as for hydrogen. So don't assume that carbon and hydrogen, for carbon to hydrogen one line, for hydrogen to carbon another line. No, this line is representing bond for carbon at the same time for hydrogen. So this bond belongs to both the atoms. Next, C2H6. How many carbons? 2, right? 1, 2. So these are alkane. Alkane means saturated. Alkanes are saturated. Saturated means definitely there will be single bond. Single bond between what? Here I told you earlier. Single, double, triple bonds between carbons only. Now, 2 carbons. Let us draw one bond here. One bond we have drawn because it is saturated. Now, draw remaining valencies for carbon. For this carbon you take. Already we have represented 1. Basically there are 4 valencies, right? Already we have represented one line. One line means one bond we have represented. How many left for this carbon? 3. 1, 2, 3. Now if you see only this carbon, it has 4. Now while coming to second carbon, already we have represented 1. I told you this line belongs to this carbon, at the same time this carbon also. So how many remaining? 1, 2, 3. So now if you see for only this carbon, 1, 2, 3, 4. For this carbon, 1, 2, 3, 4. Like that. So you have to keep this thing in your mind. Many students will be doing mistakes here only. They don't assume that this line, this bond belongs to, they will be assuming this bond belongs to only one carbon. No, this belongs to both. Now, how many carbons you have, how many hydrogens you have to represent, guys? 6, isn't it? 1, 2, 3, 4, 5, 6. Simple to represent. Next, let us represent for C3H8. How many carbons? 3. 1, 2, 3. First you have to draw carbons. Number 2, we have to represent bonds between carbons. This is saturated, alkane, single bonds. Single bond between carbon, single bond between 2 carbons. Now, next step, draw remaining valencies. You take this first carbon, already 1 is filled, 2, 3, 4. Take this second carbon, one line we have represented here. One line we have represented here. So what is the total count of second carbon now? It is 2. Because this line belongs to this carbon also. This line belongs to this carbon also. So already 2 is represented. 3, 4. Now while coming to this carbon, 1 is already represented. 2, 3, 4. Now how many hydrogens? Count 8. 1, 2, 3, 4, 5, 6, 7, 8. Now for C4H10, step 1, represent carbons. How many? 4. 1, 2, 3, 4. Step 2, represent bonds between carbons. 1, 1, 1. Step 3, draw remaining valencies. For first carbon, 1 is already there. 2, 3, 4. For second carbon, 2 already there. 3, 4. For third carbon, 2 already there. 3, 4. For fourth carbon, 1 is already there. 2, 3, 4. Next, fourth step, represent hydrogens. How many? 10. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Simple. Next, for 2, you have to repeat the process while I am drawing. So I'll be somewhat fast regarding this 2. Okay, I think so you can remember 4 steps. Step 1, represent carbons. Step 2, represent bonds. Step 3, represent remaining valencies. Step 4, represent hydrogens. Okay, let us start for C5H12. You can also draw along with me. C5, 1, 2, 3, 4, 5, because it is saturated single bonds. For first carbon 1 already there, 2, 3, 4. For second carbon 2, 3, 4. Third carbon 2, 3, 4. Fourth carbon 2, 3, 4. Fifth carbon 1, 2, 3, 4. And hydrogens 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Next for C6H14, 1, 2, 3, 4, 5, 6 bonds. 1, 2, 3. I mean bonds for 1, 2, 3, 4. 2, 3, 4, 2, 3, 4, 2, 3, 4, 1, 2, 3, 4. How many carbon hydrogens will get? 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Like that you have to draw structures. Same, we can represent for alkene, alkyne. This you have to be somewhat careful. Next, we are going with the second category, second homologous, alkene. Alkene formula we know CN H2N. So this is unsaturated. Unsaturated means at least one double bond between carbons. How many double bonds should be there? At least one double bond between two carbons. Now, formulas, if you substitute one, C1H2, that is not possible. So from 2 we can do it. C2H4, C3H6, C4H8, C5H10, C6H12. So what is the C6H12 names? This is 6 means hex. It is alkene, ene. 5 means pent, ene. 4 means bute, butene. 3 means prop, propene. 2 means eth, ethene. Now if you draw structure, how many carbons? 2. 1, 2. In between these two carbons, what bond should be there? Double bond. Represent double bond. Next, write remaining valencies. First carbon, already 2 is represented. 3, 4. That's it, guys. While coming to second carbon, already 2 is represented this side. So 3, 4. Now how many hydrogens you see? 4. 1, 2, 3, 4 hydrogens for ethene. Next, propene. How many carbons? 3. 1, 2, 3. In between carbons, at least one double bond. If you wanna draw it here, you can draw. If you wanna draw it here, you can draw. It's your wish. But once if you draw double bond here, this should be single bond, guys. Because I told you only one, right? So if you are representing double bond here, this side should be single bond. Okay, draw remaining valencies. For first carbon, 2 already represented. 3, 4. For second carbon, 1, 2, 3 represented, right? You have to calculate right hand side and left hand side both. Okay, right, left hand side 1, 2, right hand side 1, 3 represented. 4. For this carbon, only 1 represented. 2, 3, 4. Now if you draw, if you represent hydrogens, how many hydrogens? Propene, 6. 1, 2, 3, 4, 5, 6. So 3 carbons we have represented, 6 hydrogens we have represented, at least one double bond we have represented. That is a molecule, I mean compound structure for propene. You can, guys, you can draw either way. You can take this hydrogen and you can draw it here also. That is also correct. You can, it is not compulsory that you have to draw it here only. Fine. You can draw here also hydrogen. Nothing will happen. Only structure will change, but not chemical property, physical property and formula. Okay, you take butene, 4 carbons, 1, 2, 3, 4. At least one double bond. Wherever you want, you can represent, no problem. If you want, you can represent a double bond here. If you are representing double bond, remaining bond should be single between carbons. Now count. This carbon has 1, 2, 3, 4. This carbon has 1, 2, 3. 4 you have to represent. So if you observe only second carbon, now you can see 4 lines, right? Third carbon, already 2 represented here, 1 represented here, only 1 is left, 4. Now if you see the third carbon, 4 lines are there around that. Next, fourth carbon, 1 bond, 2, 3, 4. Now represent hydrogens 1, 2, 3, 4, 5, 6, 7, 8. Yes, 4 carbons, 8 hydrogens, 1 at least double bond. It is butene. So can you draw for this? 2. Easy to draw. 1, 2, 3, 4, 5 you take. Wherever you want, you can draw double bond. If you're drawing one double bond, remaining should be single bonds. And if you count valency, 1 already there, 2, 3, 4. While coming to second, 2 already there, 3, 4. While coming to third carbon, 2 already there, 3, 4. While coming to fourth carbon, 1, 2, 3 there, 4. While coming to last carbon, 2 already represented, 3, 4. If you go with hydrogens, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 hydrogens, 5 carbons. So try for this hexene. Next category is alkyne. Alkyne structure, CnH2n minus 2. This is also unsaturated, and we should have at least one triple bond between carbon. I'll draw for 3. You can draw for remaining 2. 1 is not possible. 2, C2H, 2 2's 4 minus 2 2. C2H2. C2H2 is nothing but meth, eth, ine. Now how many carbons? 2. 1, 2. At least one triple bond between carbon. Now for this carbon remaining valency, already 3 represented, 4. For second carbon, already 3 represented, 4. Draw hydrogens, 1, 2. You see 2 carbons, 2 hydrogens, right? And we have second C3H, 3 2's 6, 6 minus 2, 4. Name of this meth, eth, prop. It is prop alkyne, so propyne. How many carbons? 3. 1, 2, 3. At least one triple bond. If you represent one triple bond here, remaining should be single bond. Now remaining valency for this carbon already 3, 4. For second carbon, 3 left hand side, 1 right hand side, 3 plus 1, 4. So no need to go with any other valency. Now if you draw like this, it will become 5. 5 is not the valency, right? For the carbon, no. Next for last carbon, only 1 is represented. 2, 3, 4. Now hydrogens, 1, 2, 3, 4. So 4 hydrogens and 3 carbons. This is propyne. And for C4H6, because 4 2 is 8 minus 2 6. Name of this: meth, eth, prop, but. Category: alkyne, butane. How many carbons? 4. 1, 2, 3, 4. At least one triple bond. Wherever you want, you can represent here, 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 your wish. So if you represent 1, 2, 3 here, remaining carbons, single bond. Now valency for the first carbon, only one is there. 2, 3, 4. For second carbon, one left hand side, 3 right hand side, 1 plus 3, 4, satisfied. For third carbon, 3 left hand side, 1 right hand side, 3 plus 1, 4, satisfied, no need to represent. For last carbon, only one is represented, 2, 3, 4. Now if you draw hydrogens, 1, 2, 3, 4, 5, 6. Now how many hydrogens? 6. How many carbons? 4. Same like that, please do for C5, H8 and C6, H10. Only one triple bond, remaining single bonds, count valency, draw remaining valencies, represent hydrogens, that's it. So in this lecture we have learnt about how to name saturated, unsaturated hydrocarbons, how to write chemical formulas, how to represent it, and how to draw structures we have seen. That's it in this lecture.